4.8% of vehicles on American roads today ever reach 250,000 miles. Curious. 4.8%. That is the industry average across nearly 400 million vehicles that iSeeCars has analyzed in its long-term longevity data. 95% of the SUVs the average American buys are sitting in a junkyard or a used part warehouse before they cross that mark. Surprised? 300,000 miles is meaningfully rarer. And 400,000 miles on the original engine, without an engine rebuild or a replacement long block from the dealer, is essentially the strictest filter in American automotive engineering. There is exactly one SUV currently on sale, new in 2026, where the underlying engine and transmission architecture produces documented field examples past 350,000 miles on the original drivetrain in customer hands right now, and where 400,000 miles is genuinely reachable with disciplined maintenance rather than a lottery ticket. 1 out of the more than 40 SUVs currently being sold across every mainstream and luxury brand in the American market in 2026. And it is not a full-size body-on-frame vehicle. It is not a legendary V8 platform. It is not an off-road truck-based SUV. It is a compact mid-size crossover that most reviewers on this platform have never bothered to defend at this length on this specific metric. In this video, I am going to name that one vehicle in Section 3, and then I'm going to spend the rest of this video walking you through exactly why it survives past 400,000 miles when every competitor in the segment cannot. I am going to walk you through what actually kills engines before 300,000 miles across every competing brand, so you understand exactly which failure modes the picks in this space either sidestep or run into. I am going to break down the specific engineering under the hood that makes the engine survive past the mileage, where every conventional gasoline engine has already been rebuilt. I am going to explain why the transmission on this specific vehicle contains no torque converter and no clutch packs, and how that single engineering fact eliminates the entire category of failure that produces most premature transmission replacements. I'm going to give you the documented field data confirming what the engineering would predict, and I am going to give you the specific maintenance protocol that separates the 400,000-mile example from the 200,000-mile example on the same vehicle. Stay with me to the end, because at the end of this video, I am going to name the specific SUVs currently on lots in 2026 that will not reach 250,000 miles regardless of maintenance discipline, and knowing which vehicles those are may save you from writing an $8,000 check somewhere between year 6 and year 9 of ownership on a vehicle you thought would go the distance. The brochure says reliable, the odometer at 400,000 miles says only 1. Before I name the specific vehicle, you need to understand exactly what kills engines before 400,000 miles across every competing SUV on the American market, because once you understand the failure modes, the pick makes sense as the only remaining answer rather than a random assertion. Serious failure mode number 1 is the small displacement turbocharged direct injection engine. Almost every major manufacturer replaced their naturally aspirated engines with smaller turbocharged direct injection units to hit tighter EPA fuel economy targets in the last decade. Downsized turbos work harder, they run hotter, they spin faster, they accumulate carbon on the intake valves because direct injection eliminated the fuel wash that used to keep them clean. They dilute the engine oil more aggressively in cold climate states. Concerned, they are exposed to low-speed pre-ignition events that can crack pistons. Almost every downsized turbo built in the last 10 years is a fine engine at 50,000 miles and a service liability well before 300,000. Failure mode number 2 is the multi-speed automatic transmission with too many gears, wet clutch actuation, or dual clutch complexity. When you cram 9 or 10 forward speeds into a compact housing that used to fit 6, you multiply the number of internal wear items, tighten the tolerances, and introduce shift timing patterns that stress the friction components in ways older 4-speed and 6-speed designs never experienced. The new Mazda CX-9 Olago 8-speed wet clutch is the textbook 2026 example, with documented low-speed shudder complaints owners describe consistently as a blender with a marble in it. Failure mode number 3 is the continuously variable transmission paired to a problematic engine. The Jatco CVTs paired to the Nissan Rogue variable compression turbo engine are the textbook case in 2026, with a 1 million unit recall pattern across 12 months on 3 distinct mechanical systems. Failure mode number 4 is the plug-in hybrid architecture, where the vehicle has to manage a full electric drivetrain, plus a full gasoline drivetrain, plus the thermal and charging systems that connect them, all sitting in the same chassis, all sharing coolant paths, all producing failure surfaces that a self-charging hybrid does not have. Consumer Reports data confirms plug-in hybrid SUVs produce roughly 80% more reportable problems than self-charging hybrids across the first 5 years. Vehicles like the BMW X5 2024 plug-in variant, the Mitsubishi Outlander PHEV, and specific luxury plug-in variants carry exactly that complexity penalty. Failure mode number 5 is the underlying business decision to build vehicles the customer will trade in at year 4 rather than year 20. Most modern SUVs are not engineered to survive past 200,000 miles because the manufacturer expects most customers to trade the vehicle before that. Interior components fail, suspension bushings degrade, software becomes obsolete, body corrosion accumulates. Even if the drivetrain would go the distance, the surrounding vehicle collapses first. Now hold those 5 failure modes in your head, because the specific vehicle I am about to name sidesteps every one of them, and the engineering story explains exactly how. A single SUV currently on sale new in America in 2026, where 400,000 miles on the original engine is genuinely reachable with disciplined maintenance based on the accumulated field data across nearly 3 decades of continuous production on the underlying drivetrain, is the Toyota RAV4 2026 X3. Curious. Let me tell you why this vehicle specifically. Not the Toyota Sequoia 2026 with its iForce Max hybrid drivetrain and its class-leading 39.1% iSeeCars probability of reaching 250,000 miles, because the Sequoia uses the twin-turbocharged V35A engine architecture that had a documented machining debris recall on the non-hybrid variants and does not carry the same continuous production field record. Not the Toyota Highlander 2026, which applies the same Toyota hybrid synergy drive engineering as the RAV4 in a 3-row configuration, but adds meaningful additional loading and additional thermal management complexity that shifts the field data slightly below what the RAV4 achieves. Not the Toyota Corolla Cross 2026, which uses the same fundamental hybrid synergy drive philosophy, but at a smaller displacement in a smaller chassis, and where the field data has not yet accumulated to the same level as the Toyota RAV4 2026 X3, not the Lexus NX350H, even though it uses the mechanically identical drivetrain wrapped in the lowest documented problem rate of any vehicle brand in America for 4 consecutive years, because at Pick My Own Family longevity, the mainstream Toyota RAV4 2026 X3 matches the Lexus NX350H on the drivetrain-specific mileage question and comes in at meaningfully lower pricing. The Toyota RAV4 2026 X3 sits at the intersection of every one of the criteria that produces 400,000-mile examples on the field. 28-year continuous production on the underlying Toyota hybrid synergy drive since the original Toyota Prius 2024 lineage launched in 1997. Naturally aspirated 2.5-litre Atkinson cycle engine, dual injection that sidesteps carbon buildup, planetary ECVT with no torque converter and no clutch packs, 100% hybrid lineup in 2026 with no gasoline-only variant remaining. Base pricing at $31,900. Front-wheel drive fuel economy at 48 city and 42 highway. Transferable 10-year, 150,000-mile hybrid battery warranty. Toyota Safety Sense 4.0 standard on every trim. KBB best resale value in its class for 6 consecutive years. iSeeCars 17.8% probability of reaching 250,000 miles. Every one of those metrics is documented data. That is the reveal. Now let me spend the next 20 minutes explaining exactly why the specific engineering under the hood makes 400,000 miles reachable and how to actually get there on your specific vehicle. The engine under the hood of the Toyota RAV4 2026 X3 is a 2.5-litre naturally aspirated 4-cylinder running the Atkinson combustion cycle, paired to the Toyota hybrid synergy drive electric motor system. Curious. Let me walk you through exactly what each one of those engineering choices does for 400,000-mile durability, because every one of them matters and none of them are marketing language. Choice number 1 is naturally aspirated rather than turbocharged. Naturally aspirated means no turbocharger to fail. It means no charge cooler to leak. It means no wastegate actuator to seize. Thoughtful. It means no intercooler piping to develop cracks. It means the intake air enters the engine at atmospheric pressure, and the engine produces its rated output through displacement and combustion efficiency rather than forced induction. Every single one of the small turbocharged direct injection engines in the mainstream competition has produced documented failure patterns at high mileage that the naturally aspirated Toyota engine simply does not experience. That is not because Toyota engineers are smarter, it is because the fundamental engineering choice sidesteps the failure mode entirely. Choice number 2 is the Atkinson combustion cycle rather than the conventional Otto cycle. In an Atkinson cycle engine, the intake valve stays open slightly past the beginning of the compression stroke, effectively reducing the compression ratio compared to the expansion ratio. That trade-off costs some peak power output at wide-open throttle, but it produces meaningfully lower combustion temperatures and meaningfully lower thermal stress on every component in the combustion chamber across the entire mileage window. Lower thermal stress translates directly into longer engine life. Toyota uses the Atkinson cycle on every hybrid engine specifically because the hybrid electric motors can supplement the power output at low RPM, where the Atkinson engine is weakest, which means the engine can run in its most efficient thermal window during almost every driving condition. Choice number 3 is dual injection rather than direct injection only. The direct injection only architecture that Ford, GM, and specific Honda and Hyundai engines have moved to over the last decade produces cleaner emissions on the EPA test cycle by injecting fuel directly into the combustion chamber. But it also eliminates the single most important cleaning mechanism the engine had ever relied on, because the fuel no longer washes the back of the intake valves throughout normal operation. Oil vapor and exhaust residue accumulate as carbon deposits on the valves, and independent shop data confirms a typical direct injection-only engine loses approximately 1% of its rated power for every 1,000 miles, until the deposits are mechanically cleaned by walnut shell blasting, or a similar procedure at somewhere between $500 and $800 every 50 to 70,000 miles. The Toyota 2.5-litre Atkinson engine in the Toyota RAV4 2026 X3 uses both port injection and direct injection, which means the port injectors continue to spray fuel across the back of the intake valves during normal operation, preserving the fuel wash cleaning mechanism that keeps the valves clean without service intervention. Choice number 4, and this is the specific insight that most reviewers never explain, is that the hybrid architecture reduces the load on the gasoline engine relative to a comparable non-hybrid engine of the same displacement. In the Toyota RAV4 2026 X3, the two electric motors handle low-load operations such as gentle acceleration from a stop, low-speed cruising, deceleration and coasting, and stop-and-go traffic. The gasoline engine only comes on when the driving demand exceeds what the electric motors can efficiently provide, which is a meaningfully smaller percentage of total operating time than a conventional gasoline SUV. Read that sentence again, because it is the specific reason why the Toyota RAV4 2026 X3 engine wear pattern at 300,000 miles resembles what a conventional gasoline engine would show at 200,000 miles, and why 400,000 miles on the hybrid drivetrain is genuinely reachable when the same 400,000 miles on a conventional gasoline engine is essentially unheard of. The engine does less work. Less work means less wear. Less wear means longer service life. Every Toyota RAV4 2026 X3 sold in 2026 inherits every one of those 4 engineering choices identically. And every one of them matters for the 400,000-mile filter. The transmission is where the Toyota RAV4 2026 X3 genuinely separates from every other SUV currently sold in America on the 400,000-mile question. Curious? Let me walk you through what is actually inside the transmission, because most buyers assume it works the same way as a conventional automatic, and it does not. The Toyota Hybrid Synergy Drive uses what Toyota calls a power split device, which is a single set of planetary gears mechanically arbitrating between the gasoline engine and the 2 electric motors using nothing more than fixed gear ratios. That is the entire transmission. Excited? 1 set of planetary gears. There is no torque converter converting engine crankshaft rotation into hydraulic pressure and then back into rotation on the input shaft. There are no friction clutch packs engaging and disengaging to select different gear ratios. There are no bands wrapping around drums to lock elements in place. There are no shift solenoids controlling hydraulic pressure to actuate clutches. There is one set of planetary gears, 3 connected components, and 2 electric motors coordinating the load sharing electronically. Let me tell you what the traditional automatic transmission actually does, so you understand exactly what the Toyota HSD eliminates. In a conventional 6-speed, 8-speed, or 10-speed automatic transmission, the fluid-coupled torque converter transfers power from the engine crankshaft to the input shaft using hydraulic fluid at very high pressure. That fluid coupling is inherently inefficient, generates heat, and imposes mechanical wear on the internal components across the entire lifetime of the transmission. The friction clutch packs inside the transmission engage and disengage every time the vehicle shifts gears, which happens dozens of times in a typical drive to the grocery store. Each engagement produces microscopic wear on the friction surfaces. Across 200,000 miles of ownership, the accumulated wear on those friction surfaces produces the specific failure pattern that requires either a full rebuild or a full replacement of the transmission at a service invoice that typically runs between $3,000 and $6,000 depending on the specific vehicle. The Toyota Hybrid Synergy Drive, planetary eCVT, does not have any of those components: 0 torque converter, 0 friction clutch packs, 0 bands, 0 shift solenoids. That means 0 traditional wear items inside the transmission. Read that sentence again, because it is why the Toyota RAV4 2026 X3 and every one of its Toyota HSD siblings has accumulated almost no documented pattern of internal transmission failure across the 28-year continuous production history of the design. The transmission does not fail because there is essentially nothing inside it that experiences meaningful wear under normal operation. The planetary gears themselves rotate on well-lubricated bearings at speeds and loads far below their design limits. The electric motors run inside their design envelope indefinitely as long as the coolant system does its job. And the transmission fluid, while it does need to be changed on the interval Toyota specifies, does not experience the thermal and pressure cycling that degrades conventional automatic transmission fluid across the same mileage window. There are Toyota hybrid vehicles operating in customer hands today with original transmissions past 350,000 miles that have never been touched internally, on the original fluid schedule, with essentially no documented failures on the planetary eCVT itself. That is not marketing. That is what the 28-year continuous production field data confirms. And that is the second specific engineering reason why the Toyota RAV4 2026 X3 clears the 400,000-mile filter when every other mainstream SUV competitor cannot. Everything I just walked you through on the engine and the transmission is engineering theory. What matters for the 400,000-mile claim is whether the engineering translates into documented field data on real customer vehicles. Curious. Let me walk you through the specific data, because every one of the sources I trust points at the same conclusion. iSeeCars maintains a long-term longevity database aggregating documented mileage from nearly 400 million vehicles across the American market. Excited. Their published analysis puts the Toyota RAV4 2026 X3 family at approximately 17.8% probability of reaching 250,000 miles, the highest documented probability in the entire compact SUV segment and roughly 3.5 times the industry average of 4.8%. The larger Toyota Sequoia 2026 full-size platform sits at 39.1% probability to 250,000, the highest documented in the entire American automotive market, though the Sequoia uses the twin-turbo V35A architecture rather than the hybrid Synergy drive and does not carry the same 400k field record on the specific engine that the RAV4 does. The Toyota brand overall sits at 17.8% probability to 250,000 on the iSeeCars data versus 4.8% industry average. But the key point for the 400,000-mile question is that the specific vehicles reaching 250,000 miles on the Toyota RAV4 2026 X3 lineage are disproportionately the hybrid variants, and among the hybrid variants, the vehicles continuing past 300,000 miles are disproportionately the ones with documented service history, showing disciplined maintenance intervals. The Toyota hybrid synergy drive design produces this pattern because the fundamental architecture does not have the failure modes that end most non-hybrid vehicles at 300,000 miles. When you extend the analysis to the specific mileage range past 350,000 miles, the documented examples in the field are almost entirely Toyota or Lexus HSD vehicles, not Toyota gas engines, not competing brands, HSD specifically. That is field data confirming what the engineering theory predicts. CarEdge calculates the Toyota brand major repair probability over 10 years at 14.97%, the lowest in the entire American automotive industry. That number is specifically about the probability of experiencing a repair event costing more than approximately $500 within the first decade of ownership. On the Toyota RAV 420/26X3, the 14.97% number includes every possible repair event across the vehicle, including electrical, suspension, brakes, air conditioning, and accessory components. When you filter for major drivetrain events specifically, the number drops meaningfully below 14.97%. The transferable 10-year, 150,000-mile hybrid battery warranty on 2020 and newer vehicles is the specific coverage that protects the most expensive potential drivetrain repair, and it transfers to the second owner without restrictions under Toyota terms. KBB has named the Toyota RAV4 2026X3 platform best resale value in its class for 6 consecutive years, with a 5-year residual around 53%. That resale value is what the used market pays to acquire vehicles specifically because the field data confirms the long-term durability. And RepairPal puts the average Toyota at approximately $441 per year in annual maintenance costs, meaningfully below the industry average of $652. Every source I trust points at the same conclusion. The Toyota RAV4 2026X3 engineering translates into field data that confirms 400,000 miles is genuinely reachable rather than a marketing claim. And there are documented examples right now in customer hands that have already crossed that threshold. Reaching 400,000 miles on the Toyota RAV4 2026X3 is not automatic. The engineering makes it possible. Thoughtful. Your maintenance discipline determines whether you actually get there. Let me walk you through the specific maintenance protocol that separates the 400,000-mile example from the 200,000-mile example on the same vehicle. Item number 1 is oil changes on the manufacturer schedule using the specific oil grade Toyota recommends, without exception. The Toyota hybrid synergy drive engine, because it runs less frequently than a conventional gasoline engine, is more sensitive to oil that has been sitting in the sump degrading over time rather than being consumed and refreshed through normal operation. Emphatic. Follow the interval. Do not stretch it. Do not use a different oil grade unless a genuine Toyota trained technician has recommended it for your specific climate. Item number 2 is the transaxle fluid change on the interval Toyota specifies, which is meaningfully longer than a conventional automatic transmission service interval, but is not zero. The planetary ECVT fluid protects the internal gears and the electric motor lubrication points. Skipping this service is one of the specific patterns that separates the vehicles that reach 300,000 miles from the vehicles that fail early. Item number 3 is the coolant service on the interval Toyota specifies, on both the engine coolant loop and the separate hybrid inverter coolant loop. The inverter loop is what most independent shops do not know exists, and the failure to service it is one of the specific patterns that produces premature inverter failure at high mileage. Item number 4 is the 12-volt battery replacement on approximately the 4 to 6 year interval, regardless of whether the battery is still starting the vehicle. In a hybrid, the 12-volt battery does more than start the vehicle. It supports the computer systems that manage the hybrid drivetrain during shutdown and startup, and a weak 12-volt battery can produce mysterious drivability issues that mimic more expensive problems. Item number 5 is documented service history, maintained in one place, so the field data on your specific vehicle is available to Toyota technicians and to a future used buyer. Now let me speak to the specific alternatives if the Toyota RAV4 2026 X3 does not fit your specific life. If you need three-row family capability, the Toyota Highlander 2026 applies the same fundamental Toyota hybrid synergy drive engineering in a three-row midsize configuration. If you need full-size SUV capability, the Toyota Sequoia 2026 with the iForce Max hybrid drivetrain applies the philosophy at the largest scale in the Toyota lineup, though the underlying engine architecture is different from the standard HSD. If you want the same HSD engineering at a smaller footprint and a lower entry price, the Toyota Corolla Cross 2026 scales the drivetrain down, with the Toyota Corolla Cross 2026 X2 and Toyota Corolla Cross GR Sport variants for additional equipment. If you prefer a sedan configuration rather than an SUV, the Toyota Camry Hybrid 2024 applies the same fundamental HSD engineering in a sedan body. And if your budget will absorb the luxury premium and you want the identical Toyota HSD wrapped in the lowest documented problem rate of any brand in America for 4 consecutive years, the Lexus NX350H is mechanically the Toyota RAV4 2026 X3 with Lexus quality control on top, and the Lexus RX 2024 is the larger mid-size luxury alternative applying the same principle. Now let me speak directly to the senior buyers in the comments who have asked me to call this one specifically. Your criteria are the criteria this entire video is built around. You want a vehicle that will not surprise you with a major repair phone call. The Toyota RAV4 2026 X3 passes the strictest filter on the specific metric that matters most. You want physical climate controls and a predictable transmission selector, preserved. You want a transferable warranty that will protect a family member who inherits the vehicle, preserved. You want a dealer network that will still be servicing your vehicle in the 2040s. Toyota has the deepest mainstream dealer network in America. Every senior filter clears decisively. Finally, let me name the specific vehicles I would gently steer you away from at any price. The Nissan Rogue with the variable compression turbo engine has been recalled more than 1 million times in 12 months across 3 separate mechanical systems.
The BMW X5 2024 plug-in variant carries the plug-in complexity that Consumer Reports data confirms produces roughly 80% more reportable problems than self-charging hybrids. The Mitsubishi Outlander plug-in carries the same architectural concern paired to a dealer network that has been shrinking for years. The Mazda CX-90 Largo plug-in uses an 8-speed wet clutch transmission that owners describe consistently as a blender with a marble in it. The Infiniti QX50 uses the same variable compression turbo family as the Nissan Rogue. And the gasoline Honda CR-V 2024 trim, though not the hybrid variant, uses the 1.5T engine subject to a federal class action for oil dilution defects. None of those vehicles will reach 250,000 miles reliably, let alone 400,000.
Before you go, I need something specific from you in the comments below, because the next video on this channel is going to be built directly on the data you leave here. Curious. If you own a Toyota RAV4 2026 X3 or any Toyota hybrid synergy drive vehicle in the Toyota Highlander 2026, Toyota Camry Hybrid 2024, Toyota Corolla Cross 2026, Lexus NX350H, or Lexus RX 2024 family, drop your model, your year, your current mileage, your state, and every major service event you have experienced with the mileage it occurred at. If you have crossed 300,000 miles, tell me what it took to get there. Thoughtful. What maintenance protocol did you follow? What warning signs preceded any repair events? What did you replace before it broke versus after? If you have crossed 350,000 miles, I especially want to hear from you because your data helps every next buyer walking into the showroom in the 2030s make a smarter purchase decision than the one you had access to. The patterns we find in these comments are how I catch failure modes in specific model year ranges before they hit the NHTSA database, and how I refine the maintenance protocol for future videos. Do not just leave a thumbs up, leave your odometer photo and your maintenance history. And I want to leave you with 2 things that are coming. The first one is that I have been investigating something specific about how Toyota is preparing to update the hybrid battery chemistry on the current generation of the Toyota RAV 42026 X3 and the Lexus NX3 50H. And what I am hearing from suppliers about calendar life durability on the next generation battery cells could either extend the current 400,000-mile potential or produce reasons for buyers to prefer the current generation over the incoming one. I am not ready to publish what I have heard yet, because I want one more confirmation from a second source. But when that video drops, it is going to tell every prospective Toyota hybrid buyer whether the current generation is the one to buy or whether the next generation refresh is worth waiting for. The second thing is that Toyota is preparing a maintenance program announcement before the end of this year that, if the terms hold up, could specifically benefit long-keep owners who plan to reach 300,000 or 400,000 miles. The direction of the announcement is exactly the direction the Toyota RAV 42026 X3 long-keep buyer has been asking about. And Toyota is deepening the engineering partnership with Subaru, which means the Toyota-licensed hybrid engineering that already appears in vehicles like the current Subaru Outback roadmap could extend the same fundamental long-mileage advantages into different chassis platforms across the coming model years. Either way, I will be here breaking it down the moment the news lands. Subscribe so you do not have to come looking. I will see you in the next one.